So in this video we will try to answer the questions that is given in the so in this video I will explain how to attempt this past paper questions and get the answers, right? So we will start with the first question. So the first question says explain the methods of sampling, right? So now we have to briefly explain the methods of sampling that we have studied in this course called the survey and sampling techniques. So we classify the methods of sampling into two groups: methods of sampling, right? We divided into two major groups. The first one is probability sampling techniques, and then we studied about non-probability sampling techniques, right? Okay, so probability sampling techniques mean in the sampling process sampling process means the act or the procedure of drawing sample from the population. So each experimental unit have the equal chance of being selected to be a part of the population, part of the sample, right? So this is the definition of probability random sampling. So you can simply write each experimental unit has the equal chance or opportunity of being selected to be a part of the sample, right? So this is just a simple explanation you can give for probability sampling techniques, right? Then non-probability sampling techniques is the vice versa or the opposite of this probability sampling, where we have the we don't have the equal chance for allocating each experimental unit for the experimental categories, right? So that is the non-probability sampling technique. So you may write like this is just like a biased method, right? So you may just write whatever you know, right? So regarding this non-probability sampling, now we have different methods for probability sampling, right? So we will just name them only, but through questions we will study the related theories about each sampling techniques. So first we studied about simple random sampling, SRS, right? Then we studied about stratified random sampling, then we studied about systematic random sampling. Under that we studied about repeated systematic random sampling also, and then we studied about cluster sampling, then we studied about area sampling, and then we studied about multi-stage sampling also, right? And under non-probability sampling we have a lot of methods, right? So let me just write down them. So this is what they expect to write here for the question A part. We have studied about judgmental sampling techniques, and then we studied about convenient sampling method, and then we have studied about quota sampling techniques, panel sampling and snowball, right? Panel sampling techniques and snowball sampling techniques, right? Okay, now this is what they expect to write to be written for the first part, right? So that is okay. Now let me erase this and go to the second question. Okay. Right. In the second question, they are asking, first let me read the question. List all possible samples of size n is equal to 3 without replacement from the population to estimate the following, right? So now this question is asked about simple random sampling. Now in simple random sampling we have two techniques to draw the sample from the population. So the first one is with replacement and the other one is without replacement, right? But anyhow, in practical scenarios, without replacement has the less variance, and hence it's considered to be more efficient method. So here what you should know is, in simple random sampling we have two techniques, with replacement and without replacement, WOR, without replacement, right? So for both we have the same equation for mean. Anyhow, we have different equations for variances of x bar, right? So variance of x bar without replacement is equal to s squared divided by n minus 1 divided by n, right? This is the equation for without replacement. And for with replacement, the equation that we have is variance of x bar without replacement is equal to s squared divided by n minus n divided by n, right? So this is the equation. Now we have to compare which method is more efficient comparing the variances. So now I will just take variance of x bar without replacement is equal to, now I'm just going to take this s squared divided by n minus n divided by n. Okay, right. Now I'm going to make some modification in the numerator of this fraction part, right? So s squared divided by n, I'm just adding 1, subtracting 1 and adding 1, right? So n minus 1 plus 1 minus n divided by n, right? So it makes sense because the denominator, even though the numerator has been altered, the value doesn't change, right? So now it becomes s squared divided by n. Now I'm going to split this fraction like this. N minus 1 divided by n plus s squared divided by, okay, if I write this way you may understand, right? Okay, I'm just going to split this only. Okay. Then again plus 1 minus n divided by n, right? Now I'm going to distribute this equation considering this as a and this as b, right? So let me take this as a and this as b. So if we have something like this, right? So c into a plus b, then it will be written as ca plus cb, right? So this is just okay, anyhow I'm just telling, right? So in order to make you understand this, so this becomes s squared divided by n minus 1 divided by n, right? So this is n, not w, plus, now I'm just taking minus out from this so that I can compare easily. Okay, so I'm just writing this as minus n minus 1 divided by n s squared divided by n. Okay, right. Now this is variance of x bar, so I should have written variance, right? So variance of x bar without replacement. This is nothing but the equation for with replacement, right? So this is with replacement. This equation is with replacement. So you may write this as variance of x bar with replacement minus n minus 1 divided by n squared equal n, right? So now this is always greater than 0 because n is n minus 1, anyhow it's positive, n is positive, this portion is also positive, this is always greater than or equal to 0. So you may tell like if this is 5 and if this is 1, it should be something like this, 6 minus 1. So now you may tell, right? So I already made a mistake here. Always 6 is greater than 5, right? So I'm just considering an example in order to write this inequality, right? So variance of x bar with replacement is higher than that of variance of x bar without replacement. So if variance increases, then efficiency decreases. Efficiency of that method decreases. So we may conclude that what can you conclude? Without replacement method of drawing sample in simple random sampling techniques is more efficient than with replacement. Okay, so that is what we have to know apart from this question, right? So I have just explained a theory part. Sometimes this might be asked in your examination also. Now let me erase these stuffs and go to the question, right? So they have given a population of size 5, right? So this population contains 5 entries, and they are going to draw a sample of size 3, right? So in the population in the population we have 20, 35, 40, 15 and 10, and from here we are going to draw a sample of size n is equal to 3. Now for drawing the sample, we have the equation of all possible samples, right? So all possible samples that we can draw from a population in with replacement and in without replacement techniques respectively, right? So now if it is without replacement, basically technically or practically we will consider only without replacement because it has the less variance, so it will be efficient, right? So this will be NCN, right? So now this is equal to n minus n factorial divided by, this will be equal to n factorial divided by n minus n factorial into n factorial, right? So now again, for if it is with replacement, but this is not asked in the question, anyhow I am just introducing the equation for you, that will be n power n, right? N power n. N power with replacement mean like this. For example, if you have 3 balls in the box, right? Now in the first trial, if you take this ball out, and in the next trial if you don't put the taken ball into the container again, then that is called without replacement. We are not replacing it, right? And if you put it again and take the next one, then it is called with replacement techniques, right? This is the difference between the with replacement and without replacement techniques. Now what we will do is like this one, okay? Right, now we will attempt this question. So this is what we know. So here if you apply this equation, so all possible samples, the number of all possible samples in this experiment is equal to 5C3. So 5 factorial divided by 2 factorial into 3 factorial. So this will give you what is that, 5 into 4 into 3 factorial divided by 2 into 3 factorial. So this goes 10. So we may draw 10 possible samples. Now what we have to do is we have to find out the population parameters. Population parameters mean we have to find mean, variance and standard deviation, right? So that is very simple. Considering this population, we may easily find out, right? So this is now not necessary for me. Let me erase this. Okay, let me erase this. And this is also not necessary. Okay, I'm just erasing this, but in the exam you can't do it, right? So now we may draw 10 possible samples, right? So we may draw 10 possible samples. But if you put with replacement, then it will be like 5 power 3, right? So 5 power 3. Now we have a lot of samples, right? But that is not practically done. So we don't need to bother about that. So now we have to find the mean of these samples. So mu is equal to summation xi. Mu is equal to summation xi. I is equal to 1 to 5 divided by n, capital N, right? So now you have to add all these. Okay, 20 plus 35 plus 40 plus 15 plus 10 divided by 5. So the answer would be let me just do it. 20 plus 35 plus 40 plus 15 plus 10, right? So I am doing it right now, and along with me you also can do the question and verify your answer with mine, right? So this is 110, I'm sorry, 120 divided by 5, it gives you 24, right? So 24 is the mean of this population. Okay, right. Now we have to find out this is a population mean. Now we have to find out sigma squared also. For sigma squared we may use summation xi minus mu holding squared divided by n, right? So we can modify this equation like this. Summation, now this can be written as summation xi squared minus 2xi mu plus mu squared, right? So I'm just going to I'm just going to derive a convenient equation from this, because from the individual values subtracting the mean and then squaring and then adding some, that is obviously a lot of work, right? So divided by n, so it gives you summation xi squared minus 2 into summation xi mu plus mu squared divided by n, right? Now this will be equal to summation xi squared, and then again I'm just distributing, right? So here also we will have summation. So summation xi squared minus 2 into, now this mu is constant, I'm taking out, summation xi plus now this mu squared is constant, so I have n mu squared, okay, divided by n. Now you see here summation mu is equal to summation xi divided by n. So instead of this summation xi, I can replace n mu, right? So this becomes summation xi squared minus 2 into n mu. Instead of this n mu, again we have mu, so this becomes 2 n mu squared plus n mu squared divided by n. Okay, so now this will be equal to summation xi squared divided minus 2 minus mu squared n mu squared divided by n, right? So this becomes here I'm sorry, this is supposed to be capital N, okay, because we are dealing with population, so this is supposed to be capital N, right? So I'm just writing in this red color. So this is also capital N, here also capital N, here also capital N, right? So now here this is capital N. Now if you do this here, now this will be equal to summation xi squared, right? Summation xi squared mean we have to find out this, right? So 20 squared plus 35 squared plus 40 squared, that one, okay? So let me just copy this control C and paste here. Now this is supposed to be the summation of the square of each observation, right? So now this will be equal to square, okay, minus n is equal to 5 times mu 24, if I am not wrong, yes, 24 divided by 5, right? So now if you simplify this, let me just do it for you. 20 square plus 35 square plus 40 square plus 15 oh I'm sorry, be careful, okay, 40 square plus 15 square plus 10 square, okay, row. Minus 5 times 24 is equal to, divided by 5 is equal to 686. Okay, 686. 686. It cannot be this much. Have we made any mistake? Okay. So now you see 5 times mu square, right? So this is supposed to be 24 square. Now if I do this again, okay, 20 square plus 31 square plus 40 square plus 15 square plus 10 square is equal to minus 5 times 24 square is equal to, divided by 5 is equal to 81.2. 81.2. This is supposed to be 81.2. Okay, so let's recheck it. So let me type it. I don't know why I make such silly mistakes in calculation. Again, I don't know what mistakes I made there. Now if you simplify this, this becomes the total of this is equal to 3550 minus this becomes 5 into 24 square divided by 5. Now if I do this, it's equal to 134, right? Okay, this is the answer. Okay, right. Now we will move to the next one. Now we have found out the variance. Now the standard deviation is simply variance, right? So this is what we have already studied. So square root of 134, that is 11.5758. 11.5758369 is the standard deviation of the population. Now the second question, all possible parameters, all sample parameters. Now the possible sample the possible samples are 10, right? So 10 we already found out. Now let me just summarize the values that we have found and erase the working parts, right? So we obtained what we need here is simply population mu is equal to 24, sigma squared is equal to 134, right? So other than that I can delete everything else. So now what we have to do is you see this all sample variances and standard deviation using the sample means. Okay, now all possible parameters, right? So now we have this population. Now the possible samples, right? Possible samples. Now we have 10 possible samples, and for them we have to calculate x bar, s squared, and variance also, right? So if we find the variance, then it is easy to find the variance. So now let me create 10 rows so that I can write down . Okay, the first one is 20, 35, 40. 20, 35, 40. Then again 20, 35, 15. 20, 35, 15. Right? And again 20, 35, 20, 35, 10. Again I am skipping this 35 and 20, 40, 15. 20, 40, 15. Then again 20, 14, 40, 10. Again skipping this 15, I can write 10, 35, 10. Okay, 10, 10, 10, 35, 10. Okay, sorry. 20, 35. So first this is what I wrote. Here I skip this one. Okay, so here I skip this one. Now I can skip 20, 40, 15. Then 20, 40, 10. Again there is nothing to skip, so I may skip this, right? So 35, 40, 15. 35, 14, 15. So 35, 40, 15. Then again 35, 40, 10. Again 40, 15, 10. 40, 15, 10. So I have just skipped 2 and then written the rest, right? So 1, 2, 3, 4, 5, 6, 7, 8. I can write 2 more. How can I write 2 more? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then again, so let me check again. So now if I write this way, I can easily find out. 20, 35, 40, 15 and 10 we have, right? So 20, 35, 14, 20, 35, 15, 20, 35, 10. Then again 20, 40, 15, 20, 40, 15, 20, now 20, 40, 15, then 20, 40, 10. Then again 35. I can start with 35, 35, 40, 15, 35, 40, 15, right? 35, 40, 10. Okay. Now 35, 15, 10. 35, 15, 10. 35, 15, 10. Okay. 35, 15, 10. Again 40, 15, 10. 40, 15, 10. Again what else? Okay. So after 20, 40, 20, 40, 10, I can write 20, 40, 10. I may write 20, 15, 10 also, right? So I 20, 15, 10 also. So these are the possible samples, right? So you should be very familiar. This is nothing. Okay, you should be very careful while drawing the samples, skipping 2 pairs, then you can write the rest to form the possible samples. Okay, now x bar should be calculated by adding these 3 and divide by 3. So for this 20 plus 35 plus 40, that is divided by 3, that is equal to what here? 20 plus 35 plus 40 is equal to 95 divided by 3, 31.6666, right? So now I can write 31.666, 31.6666. Now likewise you can try find out the x bar for the remaining samples also. So let me just quickly calculate it and put here. This is right. I have just calculated the values of these means and written. I don't know how far my answers are correct. You may check, and if I have made any mistake, you may drop in the comment, because I'm going to do the rest of the questions based on this calculation. But you just, if there is any mistake in the calculation, then okay, you just can follow the method. Then for the final answer would be calculated according to what I explained. Okay. Again, we may find out, we may need this summation also. Now if you add all these values, then you should get 240. Okay, right. Now here is now this sample variance also can be calculated. So for that you may use this equation, this one, like this minus this square, this minus this square, this minus this square, divided by 2, right? Because n minus 1. So here we have 3 minus 1. So you should write like this. Okay, 20 minus this value square plus 35 minus this value square plus 40 minus that value square divided by 3 minus 1. So the answer would be the answer would be 108.333. 108.333. Now again I will just write down the remaining values also. So it becomes 108.333, 108.333. This also this becomes 158.333, 158.333, and you may just calculate, and the final summation will be we don't need that. So if we need that, then I will calculate. Okay, so I'm just skipping this part for you. Okay, you may just try and find the individual sample variances. Okay. Now you see this. Okay, done. And standard deviation. For standard deviations also you have to make a column and you have to write down the square root of this value. For that you will obtain marks, because this is a 25 mark question. Okay, now we will move to the third question. Let me just try that question separately here. Anyhow, we will just read and come to this place. Using sample mean, estimate population mean and variance, right? So using sample means, right? So sample mean means, so mu is equal to nothing but summation xi bar divided by n. N is here 10, right? So here we have 10 samples, right? So now if you take the mean of these means, then it will be the population mean. Now here this is 240, we have 10 samples, so this is this n is, now this is not sample size. Okay, now this is number of possible samples, right? So here this n is not sample size, which is 3 in the case of this question. This is a number of possible samples, so this is 24. That is okay. Now again we have to calculate this sigma x squared, right? So this is a without replacement technique. So the equation sigma x bar squared is equal to sigma squared divided by what is this n into n minus 1 divided by n. Okay, now we have to find what this is. Now this we have we need to calculate we need to calculate the variance of this x bar. So what we can do is sigma x bar square is equal to summation xi bar minus mu holding square divided by m or n. N means okay, now for example if you put m here, then that will be easy for you, right? So now this is m. Now I'm going to consider this as a population, right? So this is a population. Now I can rewrite this as summation xi square minus summation x holding square divided by n. We can write this way also. Earlier also I converted this equation into another form. Now you can write this equation this way also, divided by m. Now if this is m, this is also m. Okay. Now if you substitute these values, now you have to find out this one, right? So you have to square all these means and then add them together to find out. So this will be equal to 5983 5983.5 333 minus, this is already 240 divided by 10 divided by 10. So if you simplify this, it becomes 22.333, right? Now in this equation we are going to substitute this one, right? So sigma square is equal to n sigma x bar square into n divided by n minus 1. So now if you substitute this, this n is 3, okay, this n is 3, and this one is 22.3333 into this n is 5 divided by 4, okay, divided by 4. Now if you simplify this, let me check if I also get the correct answer. So this will be equal to let me use the calculator. 3 times 22.33333, okay, into 5 divided by 4 is equal to 83.74. I get 83.74. But earlier I got 134. I remember already also I got this value. I think there is a mistake here again. Oh, I'm extremely sorry. The equation I used here is wrong, right? Because this is without replacement. So without replacement means it is supposed to be simple n, right? So now if I do this here, this becomes n minus n, right? N minus 5 minus 3 means 5 minus 3 means 2, okay? So if you divide it by 2, then it becomes 167.4999, but it is supposed to be 134. This is not equal, no? Anyhow, I can't figure out the mistake I have made here. Anyhow, it is approximately 134 mean 164. Okay, so you may just check what mistake I have made and let me know in the comment section. But you should have gained the idea of how to attempt this question, right? So let me skip this part and move to the next one. Now we have to find out what is that. Estimate bound-on error of estimation for any two samples, right? So bound-on error, right? So for all samples we can find out bound-on error. So for calculating bound-on error, we have the equation bound-on error B is equal to 2 square root of variance of x bar, right? Variance of x bar. So now 2 into square root of this can be s square divided by n minus n divided by n, right? So for each sample mean this would be Si, right? So if I consider the first sample, 20, 35, 15, right? 20, 35, 15, and for that the Si squared is 108.335. So I may write this as 2 into square root of 108.333 into n minus n 5 minus 3 divided by 5 divided by 3. This will give you the value, okay? And for another sample also, whatever the sample you prefer, you can find the bound of error. And then error estimate. Okay, now for the previous question, fourth part, now they are asking confidence interval. Confidence interval is equal to x bar plus or minus b, right? So if you use this for the first one, if you use, now for x bar is that 331.666, right? So 31.6666, then you can replace the bound on error, and from that you can calculate the lower value and upper value, and you can finally interpret that the mu of population lies between this and that. That is, Now we will move to the second question. So the second question says to explain the bound on the error of estimation. So for this kind of question, how you have to write the answer is following. Right? The following method I will now explain step by step how you can write the answer for the second one. Okay. Let me erase all these. Okay, so now if you go to the second question, now we have to explain the term clearly, which is bound on the error of estimation. Okay, so let me write down bound on the error of estimation. Okay, bound in the error of estimation. So now let's say we have a population and the population parameter is theta, and from the sample we have from the population we have a sample. Now this is population and let's say this is theta head, right? So estimated theta head. Now this is sample. Now we should know any estimated theta head of the parameter theta of the parameter. Now we call this as parameter and this as estimator or statistic. Okay, the summary of the statistics is called statistic or estimator. Now this theta head is unbiased if, so we can write any estimator theta head is of the parameter this is the estimator of parameter theta is unbiased if expected value of theta head is equal to theta, right? So in that scenario only that will be unbiased. Now bias of an estimated theta head, right? So bias of the estimated theta head of the parameter. This is how you have to write down the answer. Parameter theta is bias of theta head is equal to expected value of theta head minus theta. Okay. Now mean square error of an estimated theta head. Now we have to define the term mean square error, right? Mean square error of an unbiased estimator. Theta head of the parameter. Theta is now MSE theta head is equal to bias theta head holding square. Bias theta head holding square minus variance of theta head. Okay. Now error of bound on the error. Now you see bound on the error. This beta is equal to bound on the error of estimation is called beta. Then that will be equal to 2 square root of variance of theta head. Okay. Now at 95 confidence interval, 95% confidence level, CI for population mean is equal to y bar plus or minus b. Now this b is equal to 2 into square root of variance of theta head. Now this is actually the b. Okay. Now this is actually the b. Now sometimes if we use z, then that would be 1.96. Now this is equal to approximately 2. Now this is how you have to write. Okay. Now the bound on the error mean the upper and lower limits will be coming, right? So the upper and lower limits will be coming. So you have to clearly explain this situation. Now we will move to the B part of the second question. Let me erase all these explanation items. Right, now they are asking, show that the bound on the error of estimation beta, okay, sorry, B is equal to this, right, when estimating the population total in a stratified random sampling. So they are asking about this population total. Now you should know some knowledge about this stratified random sampling. Now stratified random sampling is the method that we apply for a heterogeneous population. Now if we consider the population homogeneous, then we can go for simple random sampling. We can allocate the sample. We can simply draw the sample and then conclude the summary, and from that we can infer the parameters of this population. That is what we do in simple random sampling. Now if it is heterogeneous, if this population is heterogeneous, right, so let me just explain what this stratified random sampling. Now this is population. Now this population is heterogeneous. Heterogeneous mean, for example, you might have studied about homogeneous solution, heterogeneous solutions in chemistry. Heterogeneous mean not different, right, not same, right, or having different features, right. Now this heterogeneous population should be divided into homogeneous strata. Okay, now we have to divide it into homogeneous strata. Now let's say this is n. Now this is n1, n2, n3 up to nk. Now we have divided the entire population into k strata, k divisions. So those are called strata. Okay, right. Now from each strata we draw sample. So for that we have some sample allocation. We have studied 4 types of sample allocations. First one is equal allocation. So in equal allocation, irrespective of the strata size, we equally allocate the samples for each strata. Okay, right. And then we have studied about the proportional allocation, and then we have studied about Newman allocation, and then we studied about optimum allocation also, right. So for each type of these allocations, you should know the equation separately and how to derive them and how to apply them in the research activities and the real life scenarios. Now what you want to show is this population total, right. Before finding out the population total, tau head is equal to n x bar. So x bar stratified. Now x bar stratified is equal to 1 divided by n summation ni xi bar, right. So which means if I write this expanding this one, so now if first I want to find out the total of this population. So if I multiply n1 by its respective stratum mean x1 bar plus n2 x2 bar up to nk xk bar, then it will be the population total, and then divide it by the population size. Now this will give you the x bar stratified. Now this is the condensed equation, right. Now tau head x bar. Now I have to take variance both sides. Variance of tau head is equal to variance of n x bar stratified. Now this n is constant, so I can take it outside of variance, so it will become squared, right. So n squared variance of x bar stratified. Now we have to find out the variance of x bar stratified, okay, in order to substitute in this portion of this variance of total equation. For that what I have to do is simple, right. Again I have to take variance both side of this equation. So now if I do that here, okay, so variance, okay, variance of x bar stratified is equal to variance of 1 divided by n summation ni xi bar xi bar, right. Okay, Now you see summation I is equal to 1 to k, right? I is equal to 1 to k. Now this can be written as variance of so now we can write this as variance. Now this 1 over n squared can be taken out. Variance, now this can be taken out. So if I take that outside, so it becomes 1 over n squared variance of summation variance of summation in I xi bar, right? Now you see, if you consider this stratum, now in each stratum we are going to apply simple random sampling with standard deviation of I, right? So now how I can expand this is, now this can be written as 1 over n squared summation. Now ignoring the summation, I am going to extend this in, right, so that I can easily go to the answer, right? So this can be written as n1 xi bar variance of ny xi bar plus n x1 bar plus n2 x2 bar up to plus nk xk bar, right? Xk bar. Now if I take the variance of these each term, right, so this can be written as 1 over n squared n1 variance of n1 x1 bar plus variance of x2 variance of n2 x2 bar plus up to variance of nk xk bar, right? Now 1 over n squared. Now in this here n1 is constant, so I can write this n1 x variance of x1 bar plus n2 variance of x2 bar up to this one nk variance of xk bar, right? Now here we have already studied the equation for simple random sampling, right? So Si squared variance of x bar is equal to Si squared divided by n minus ni divided by ni, right? So this is what we have studied. So here if it is ni, this is ni, right? So if I consider the ith stratum, now it will contain n, the stratum size is ni, then the population size is ni. So now this can be written as 1 divided by n squared n1 n1, okay, now summation n1 variance of, now I can write this way, okay? Now this can be written as variance of this one. So now this can be written as n1 ni, so summation ni variance of sigma xi square. So instead of the sigma xi square, I can replace 1 over n square summation ni. So this one si square divided by ni minus ni divided by ni, right? So this is what they have asked, right? So now in the question, if you look at the question, this portion is there, ni square, this one is there, okay, this one is there. Now this is nothing, right? So they have found out b is equal to 2 into variance of x toe head, right? Variance of toe head. Now you see variance of toe head, right? So I have found out this variance of x bar stratified. Now if I substitute this in this equation, it will become n squared 1 over n squared summation ni si squared divided by n ni minus ni divided by ni, right? Now this and this will go, so we end up with summation ni si squared divided by ni minus ni. Now b can be written as two variants of toe head. So now if I substitute toe, summation ni si squared divided by ni minus ni divided by ni. So this is what we wanted to show and we have done, right? Okay. Here it is supposed to be ni squared, but we have done ni only. Okay, here ni squared is there. Okay. Again I found a mistake. Okay, so here when you take this variance outside, here if you take this n1, then it will become ni squared, right? So this is also ni squared. So here if you substitute this here, this is also ni squared, this is also ni squared. Okay, so you have to be very careful. Now we have done this part. Now let me erase all these and go to the next question. Okay. Okay. Now we will move to the C part. A quality analyzer wishes to achieve information on the productivity of a manufacturing company. The department managers were interviewed by mobile and asked to rate the productivity on a numerical measure. The departments are located in 3 countries, Germany, Sweden and Italy. Hence stratified random sampling is used, right? So they have mentioned the method of sampling that they are going to go for this research. The costs are also given. So we will have to use this optimum allocation also, right? What else? The summary data is given here, right? So the summary data of the samples are given, right? Okay. Now we have the entire country. The entire country is divided into 3. Now n1 is 140, n2 is 100, and this is. So we can calculate n is equal to n1 plus n2 plus n3. Now this will be equal to 140 plus 100 plus 60. So it will be equal to 200. 200. No. 300. Okay. 300. Then they are telling the costs also, right? Now we have to convert this table to another format, right? So that we can insert another column whenever needed, right? Something like WIC, those things, right? So now stratum Ni is given. Ni is given. So Ni is given. What else? Ci is given. Si squared is given. And Ci is also given, right? Ci is also given. Now for each stratum, stratum 1, country 1, stratum 2, country 2, stratum 3, country 3. Now this is what is the values? What are the values? 140, 140, 100, 60, right? And here SI squared. This one 4, 5 and 2, and here 12, 18, 24. Okay, now you see this. Now what is the question? Now x bar stratified is given. Variance of x bar stratified is given as 0.3, right? And we have to find out if the company wishes to make Newman allocation for these countries. Newman allocation, assuming approximate equal cost estimate suitable allocation for these three countries. Now for Newman allocation and optimum allocation, the variances are slightly same. So if we consider the same cost, then we can find out Newman allocation. We can perform Newman allocation for this, right? Right. So now, even though they have asked to find out the Newman allocation things, since they have given the costs, we are supposed to find the what do you call, optimum allocation results also, right? So for optimum allocation, we have to find this sample size, right? So sample size. So the sample size. So how many sample we are going to allocate? How many sample we are going to allocate using our. Now you see, this is the case, right? So we have some amount of money, right? We have some amount of money. Utilizing this money, how many samples we can draw? That is what we have to find. So n should be calculated because that is not given, right? And based on that n, we are going to find out for each stratum how much sample we are going to draw, right? So now for this n is equal to summation I is equal to 1 to k NISI divided by Ci. Okay, NISI divided by Ci. NISI divided by Ci into summation NISI square root of Ci divided by summation of this one. N square D plus summation NISI square. So using this, we can find out the sample size, right? So now in optimum allocation, we can find out the sample size. Now for this, we need D also. For D is equal to B squared divided by 4. So B squared is nothing but now this is for x bar is given, right? So where B is equal to 2 into square root of variance of x bar stratified. So 2 into square root of 0.3. So now 2 into square root of 0.3 holding square divided by 4, it will give you 0.3. Okay, 0.3. Now we have to find this and this. Now I am going to extend this table, including inserting 2 more columns, right? This is for NISI divided by square root of Ci. Here NISI square root of Ci. Okay, right. Now Ni square root of Si divided by. Now if you calculate this, it will become 969.9485, and this becomes 948.6833, right? 6833. Again it becomes 415.6922, and we will need this summation also, right? We will need this summation also. For that the summation becomes 2334.2, okay. 2334.324. You can check your answers. Now we can calculate this also. Ni into square root of this into square root of this. So it becomes 80.829, and this becomes 52.7046. Then it becomes 17.3205. Now the summation also should be found. So 150.8541. Okay, now we can substitute the values here in this equation. 2334.324 into 150.8544 divided by this n squared. N squared is 300 squared into 0.3 plus this summation is also necessary, right? So now NISI squared summation. So NISI squared multiply this 2 and this 2 and add. So if you add them, you will get 140 into 4 plus 500 plus 120. So 1080, right? 1080. So if you simplify this, you get 12.496. 12.496. So approximately we will take 13 samples, right? So we have to allocate 13 samples. From the total number of samples that we are going to take from all these 3 countries is 13. Okay. Now using this proportional allocation, using this Newman allocation and optimum allocation, we have to find out the now you see, now using this data, now what they are telling is using to make the Newman allocation for these countries, right? Newman allocation for these countries, right? Now using this data based on the cost, we have found out we have to select 13 samples. Now we have to consider assuming approximately equal cost, right? So that is called, we are not going to go for optimum allocation for this sampling. I mean, like for example C1, now N1, N2, N3 should be found. Now for this, and we are not going to find using this proportional, I mean like optimum allocation. We are going to go for only Newman allocation, right? So if you use that Newman allocation here, and estimate the suitable allocation for these 3 countries. Estimate suitable allocation, right, for these 3 countries. So now the total samples we are going to take is 13. So if you use this Newman allocation, Ni is equal to N into NISI divided by summation NISI, right? Okay, so summation of NISI is what? Now we have to find that also, right? So 140 into 2, 280. Now 100 into square root of 5, 100 into square root of 5, 60 into square root of 2. So if you calculate this, you get 280 plus 100 square root of 5 plus 60 square root of 2. So it becomes 588.4596, right? So now this is the equation that we are going to use. So for N1 is equal to, N is 13 into NISI, this one, NISI 280 divided by 588.4596. N2 is equal to what? 13 into this one, 100 square root of 5 divided by 588.4596. N3 is equal to 13 into this one, 60 square root of 2 divided by 588.4596 is equal to. Okay, now if you simplify this, you should get this should be 6.1 something. So you can approximately take 6, and here this should be 4.9. 4.9 means you can take 5 samples, and here you get 1.8, so approximately equal to 2 samples. So if you add all these, you get 13, right? So this is what we have to answer, right? Now using optimum allocation theory, we have found out the total number of samples, and considering we are going to spend same amount of money for each country, we have calculated the sample size we are going to get from each country, that is from country 1, 6, 5. So now if you spend 1000 rupees, I'm just telling, okay, So for each country we are going to give 30 rupees. Now since this has 140, we are not going to allocate more money for the country one. This is the idea. Okay, now we will move to the third one. We will move to the third one. Okay, right, third one. So again they are asking about briefly explain systematic sampling. So systematic sampling means that is also similar to simple random sampling. So if let's say we have 100 people, and considering all are homogeneous, we are going to take 20 people, right? So if it is simple random sampling, we may use randomly to like 20 people, or otherwise we may use random number table. Now if we want to adapt to a system, right, we have to follow something called we have to randomly select the starting point, and from that starting point we are going to take the other remaining samples according to an interval. So we will call it a sampling interval. K is equal to population size n divided by n, right? So here 100 divided by 20 is equal to 5. So now how we are going to take these 20 samples is, now if I start from I is equal to I plus k, then I plus 2k. Likewise I will take the samples, right? I plus then tk, right? I plus tk. Now if I is equal to 3, then I will take 3 comma 8 comma 13 comma and so on. Okay, this is how we are going to take this, right? Okay. Now you see here briefly explain systematic sampling. Now you can write another way of like, now whatever I have said you can write in your sentence format, right? And briefly explain the reasons for considering systematic sampling as an useful alternative to random sampling. Now if you consider SRS, if you use this random number table, different people, if the research is done by, okay, now for increasing the efficiency or checking the efficiency, if the research is done by more than one people, then we can compare the answers. But if you take simple random sampling and if you take random number table, then all people will give different answer, then you can't compare or you can't check, right? But if you adapt to this systematic random sampling, then okay, person A has calculated something, person B also has calculated something. If they both are same, then we can verify that okay, the method is correct or the research is good or the whatever, right? Okay, now what else? Briefly explain the reason for considering systematic sampling as a useful alternative to random sampling. And here we adapt to a system, so the procedure will be uniform. Whatever you want you can write, right? So in the exam hall, whatever comes to your mind should be written. Now we will go for the C part. Okay. Now we will go for the C part. So this one, the administration of XYZ company is concerned in estimating the proportion of preferring a new investment strategy. A 1 in 10 systematic sample is obtained from the leaving a building, right? So now they are telling there is a population size of 4,000. There is a population size of 4,000. And they want to select a 1 in 10 sample, right? So the K is 10. Okay. Now how many sample size we need to draw can be calculated using this. So K is equal to n divided by simple n. So n is equal to capital N divided by K. So 4,000 divided by 10. So it will give you 400. Okay. Now we have to select 400 samples from the population. Okay. So now you see this. Now if we start the Now you see, now from 1 to 4000 we have numbered the sample, and we are going to start from the third sample, right? Now the second sample number will be 13, because we have to just add the k with I, right, which is the starting point. Okay, now they have responses, right? So response mean if we take 1 is yes and 0 is no, right? For the question they have asked, they have given the responses. If we 1 is yes, then okay. So summation of yi is equal to 240. Okay, 240. Now what they are asking is now this is what they okay. Now what they are asking is this is yi, right? So if you add all these, 240 means 240 people have positively replied, or like they have preferred the whatever, like that, like this, right? So p head is equal to 240 400. So out of 400 only 240, so this is 0.6. So q head is equal to 0.4, right? So we can tell, because these are the probabilities, right? So proportion means that should be added to 1. Okay, right. For the condition sketch in 1, determine the sample size required to estimate p to be within the 0.02 unit. So they have given this b, right? So they have given this b. So now what we have to do is we have to find out n is equal to p head q head divided by n minus 1d plus p head into q head. Now we need to find out this d. D is equal to b squared b squared divided by 4. So this is 0.02 square divided by 4. So it gives me the answer as 1 power 1 into 10 power minus 4, right? So if I substitute these values in the equation, 0.6 into 0.4 divided by n minus 1. So now the sample size, I'm sorry, this n is the population size, that is 4000 minus 1 into 1 into 10 power minus 4 okay, plus 0.6 into 0.4. Now if you simplify this, it should give me the answer as 1500.2344. okay. So now approximately we can take 1500, or we can add one more sample and take 1501, right? 1501 samples, right? So this amount of sample we should take, otherwise we can just ignore this decimal and take 1500 also, only one sample. Okay, so okay, now the second part, right? So this is the first part, right? So we have determined the sample size. So what type of systematic sample should be run? Now you see, we have to select 1500. Now n divided by n will be equal to k. So 4000 divided by 1500 will give me okay, let me write it clearly here. So what I want to find out is k is equal to capital N divided by simple n, 4000 divided by 1500, that is equal to 2.664. So approximately this is equal to 3, right? So now we are going to take 1 in third systematic sampling plan should be run, right, for this. Okay, now that's all for the third question. Now we will move to the fourth question, right? Okay. Okay, in the fourth question, in the A part, they are asking what is the main objective of sampling survey design, right? So sampling survey design mean in statistics what we do is we will have a population, and from the population we will take the sample. Now this is sample, and what we will do is we will obtain the information about the population using the summary of this sample, right? So now you can write the main purpose of sampling survey techniques or sampling survey design. Sampling survey design is to obtain information about the population by drawing a small portion from it through inferential statistics. So we call that process as inferential statistics, right? Okay, inferential statistics. So I hope this is the answer they expect for the question A, and now we will move to the question B, right? Okay. So again in the B part they are asking, a private hospital charges admission by parking hours rather than by persons. A hospital administrator wants to estimate the total number of hours that the car stayed at the hospital parking in a particular day. He wants from past experience that there should be about 400 cars entering the hospital, and he wants to sample 80 cars. So we have to draw information, or we have to summarize the paragraph and draw information. So n is equal to 400 and simple n is equal to 80, right? Now to obtain an estimate of the variance, he used repeated systematic sampling. So now the repeated systematic sampling is an extension format of systematic sampling in order to reduce the systematic bias by repeating or due to periodicity. Periodicity means we are going to take some more samples, or the sample is going to be divided into several samples, and now we are going to find it, right? So this is what we are going to do here. Now the purpose is to avoid systematic bias by repeating it, right? Okay. So now here you see 10 samples of 8 cars. So now these 80 samples now are going to be divided into 10, but each sample will contain 8 cars, right? So now the data is also given here in this table. Okay, right, and now they have given some values also here, 12, 34, 1. Okay, cars with these numbers from the random sampling, starting point of systematic. Now for each sample we are going to use random table, systematic sampling size, right? But for the first sample we will take 12th car as the first starting point, and for the second sample we will take 34th car as the starting point, and for the third sample we will take the first car as the starting point, and for the fourth sample we will take the 39th car as the starting point, and so on, right? So you see this, we have 10 samples and the data is given. So the random starting point and the second car, second, third, and so on, right? So we have 8 cars, right? And this is sample 1, this is sample 2, and sample 10. Okay. So here the first car is 1, and we are going to use the random starting point, which means here you see 50. So 400 divided by 80 is the k, right? So 50 is the 400 is divided by 80 is equal to 5, right? 5 means 50, right? So for each sample we will take 5. Okay, 5 is the k, 5 is the k, then 50. Otherwise you can just see this picture, 454, right? So the interval k is equal to 50. So if it is 1, then we will take the 51st car as the second element, and 11 likewise, right? So this is 151 and so on, and you are supposed to fill in these blanks also. For that you will receive marks, right? So if it is 45, 95, then you have to add 50 and 145 and so on. Now within the brackets the time the each car stayed in is given. Okay, so what we have to do is estimate the missing values in the above data layout. That is what we have done. You have to fill in the blanks. Okay. The average number of hours that the car stayed at the hospital parking. For this, what we have to do is, now you see average number of hours that a car stayed at the hospital parking. For that, we have to find out the sample, I mean the means of all these sample, right? So now we have to create another column where we will find out xi bar, right? Xi bar, the mean of each sample, right? So how you can fill this table is kind of right. You are supposed to add all these values given in the parentheses and divide by 8, right? So 4 plus 2 plus 1 plus 1 plus 2 plus 4 divided by 8, and you will get these values. Okay, let me just write it down here. 2.375, 2.375, and here 2.25, 2.25, here 3, 4.125, 125, here 4.375, 4.375, here 4, 4.125, here 4.5, here 4, here 4.125. Okay, now this will be the summation of xi. Summation of xi bar is equal to 36.875, 36.875. Now you see this is this summation of, now mu is equal to this divided by number of samples. Let me take it as ns, right? Ns, number of samples, divided by 10. So 3.6875 is the mean average number of hours that the car stayed in the hospital parking, right? So this is the answer for the second one. Now estimate the bound on the error of estimation for average. Now what they are asking is variance of mu head, right? Variance of mu head. So variance of for this we have this equation, n minus n divided by n summation xi minus mu xi bar minus mu divided by ns minus 1. Okay, now here 400 minus 80 divided by 400 into now you see this, you are supposed to subtract all these values from this, and this is like this minus this square plus this minus this minus this square plus this minus this square, this minus this square, and so on, right? So you will get this value as 6 if you calculate it, 6.164053 divided by ns is 10 into 10 minus 1, and if you simplify this, you will get the answer as 0.0548. okay, again what they are asking is estimate the bound on the error of estimation for average. So b is equal to 2 into square root of variance of mu head, right? So that is what they are asking, 2 into square root of 0.0548, and you will get the answer as 0.4682, 0.4682, right? So this is the answer. Now the fourth one, estimate the 95 confidence interval for the average. Again, so CI for average at 95 confidence interval is equal to mu plus or minus b. So this one is 0.0548 plus or minus 0.4682, and you will have lower bound and upper bound, then you can interpret your answer as well. And again, estimate the bound of another total, right? So for total, we have to find out total is equal to what do you call, mu into n, right? So that is mu is here, this one, 0.0548 into 400, right? So what is the answer here? So this is equal to 400, right? So this is equal to mu head. Mu head is, we have already calculated mu head is, I'm sorry, this is not mu head, right? So mu head, what we have calculated, this one, I'm sorry, let me just check, this is okay. mu head is not this value, right? Mu head is this value. Mu head is 3.6875 into 400. The answer is 14,750. 14,750. Now this is total, and variance of toe head is simply n squared into variance of mu, right? So n squared is 400 squared into variance of mu we have already calculated as 0.0548, and if you simplify this you will get 6800. So this is the answer that they have asked, right? So estimate the bound on the error of total, estimation of total. So bound on the error is equal to 2 into square root of this. So 876,800. The answer is what is that? 1872.752, right? So this is the answer. And for total confidence interval, this total toe head is this, plus or minus this one. Okay, so that's all. I hope you have understood this past paper answer also, and I will try to upload another video explaining the next past paper. So bye.